Hey everyone, so there was a minor update to the ALEKS system regarding plotting asymptotes when graphing rationals. This is not an update that we had any control over, but it's definitely one that we wanted to make you aware of as you prepare for your test. So if you're looking at your Unit 3 practice problems for Math 1610, this update affects problems 9 through 15. And I'm going to work a couple of those problems with you in this video so you can see how those asymptotes are done differently. So let's first take a look at number 9. So it says graph the function by using transformations of the graph y equals 1 over x, plot all necessary asymptotes. For vertical asymptotes, make sure there are at least 2 points on each side. So we know that vertical asymptotes, let's start with those, come from the factors in the denominator that do not cancel. The factor in this denominator that doesn't cancel is x plus 1. So if we set x plus 1 equal to 0, we get x equals negative 1. So that means that we should have a vertical asymptote at negative 1. Now, in the previous version of this problem, you used to be able to just click the vertical asymptote tool and then go and click on negative 1. But that's not what it's doing anymore. So let me show you again. When you click the vertical asymptote tool, this plot an XY coordinate box is going to pop up. So you have to plot a coordinate on the vertical asymptote or where you want the vertical asymptote to fall. So we all agreed a second ago that the vertical asymptote is at negative 1. So I'm going to plot the point at negative 1, 0. What it's telling the program to do is draw the asymptote through that point. So since our asymptote was at x equals negative 1, we did negative 1, 0. If your asymptote was at x equals 4, you would do 4, 0. If your asymptote was at x equals 7, you would do 7, 0. It's whatever the asymptote is and then 0 for your vertical asymptote. So I'm going to say draw asymptote. Okay, and then I can X out of that and it's got my asymptote exactly where I want it. Now we know that the horizontal asymptote is 0. Remember, that comes from our horizontal asymptote rules. When the degree in the numerator is less than the degree in the denominator, well, we have a horizontal asymptote of y equals 0. And that's the situation that we have here, because the degree in the numerator is 0 and the degree in the denominator is 1. So numerator degree is less than denominator degree, which makes the horizontal asymptote 0. So if our horizontal asymptote is at y equals 0, we're just going to click the horizontal asymptote tool here, and we're going to tell it to plot the horizontal asymptote at 0, 0, because that's a point on that line. Then again, we click draw asymptote and click the X, and there's that asymptote. And so now we're ready to plot our 2 points on either side of the vertical asymptote, which is exactly what we did before. So I'm going to click the plot a point tool. Okay, and let's see, my vertical asymptote was at x equals negative 1. So I'm going to plug in negative 2 and negative 3. If I plug in negative 3, 1 over negative 3 plus 1. Negative 3 plus 1 is negative 2. So when I plug in negative 3, I get negative 1/2. So I'm going to plot that point. Now I'm going to do negative 2. So negative 2 plus 1 is negative 1. 1 over negative 1 is negative 1. So when I plugged in negative 2, I get negative 1, plot point. So those are my 2 points to the left of the vertical asymptote. Now I need to do 2 points to the right of the vertical asymptote. So I think I'll do 0 and 1. Okay, so I'm going to plug in 0 first. So that's my x value. So you see I go ahead and type 0 here. Now if I plug in 0 to this function, 1 over 0 plus 1 is the same thing as 1 over 1, which is 1. So I'll plot that point. Then I'm going to plug in, the value of 1. Okay, and when I do that, I have 1 over 1 plus 1, which reduces to 1 over 2, so 1/2. Okay, and plot point. Once I have my 2 points on either side of the vertical asymptote, I still click the graph a function tool, and it graphs it for me really easily. And I'll check that just to show you that it's right.